This is a video lesson on congruence and specifically on congruent triangles. Congruent triangles are exactly the same, and congruence in general means exactly the same. What that means for triangles is that they have all of the same angles and all of the same side lengths. So these two triangles, triangle ABC and triangle DEF, are congruent. They each have a 7, 8, and 12 side length, 7, 8, 12. They each have a 25, 35, and 120, 25, 35, 120. They're exactly the same. You might be asking, what happens if they have the same side lengths but in a different order? And depending on how you look at it, if you're reading it clockwise or counterclockwise, or from the top and then to the bottom, or to the top and to the right, it might look like they're in a different order, but they're actually the same. And you might be asking, well, like here, for instance, the 35 degrees is in between the 7 centimeter side length and the 12 centimeter side length. What if you had a 7 and a 12 and you had a different angle there? Like what if the 25 or the 120 was there? And the answer is that if you have all three sides the same and you have the same angles, they have to appear in the same place. Fun fact about triangles, you can decide if it's fun or not, but the smallest of the three side lengths, in this case 7 centimeters, and the smallest of the three angles, in this case 25, they have to be opposite each other. And the largest of the three angles and the longest side length, they are opposite each other. And the middle side length and the middle angle, they're opposite each other. So if you have the same three lengths and you have the same three angles, they have to appear in the same relative position. Otherwise, it's not a possible triangle. So this is what congruence means. There are also other ways to show congruent measurements. Like instead of writing in the actual length, you could do something like this. These triangles, ABC and DEF, are also congruent because you'll look here. These lines that have a single dash through them, it's the same indication. That means that they're equal to each other. As opposed to these, which are both 2's, but this 2 dash is different than the 1 dash. And the fact that these are the same as each other means that they're equal, and same for the 3 dashes. Those are equal to each other. Similarly, for angles, instead of writing in the actual numerical angle in degrees, you could do something like this. Angle A and angle D have the same indication. They have sort of like lines curved through the angle. And same for here. Angle E and angle B are the same. They both have 3 of those lines. And angle C and F each have an asterisk, like a star. As long as the symbol is the same in both cases, it means that those angles are equal. It doesn't matter what the symbol is. Okay, so one of the most important things about congruence in terms of exam questions is figuring out which things are congruent, and to do that uses the minimal conditions. So obviously, if we knew all three sides and we knew all three angles, we would know that something was congruent, or rather two triangles are congruent to each other. But it's possible to prove that two triangles are congruent even if you don't know all three side lengths and all three angles. These are the minimal conditions, and I'll do my best in a couple minutes to explain those. So condition 1 is that you know all three sides. If you know all three sides, the angles have to be the same. If you know two sides and the angle contained between those two sides, SAS is a shortcut for that. That's a minimal condition to prove that things are congruent, and same for two angles and the side length contained between them. So here's the first one, side, side, side. If all three sides are the same, the angles are forced to be the same too. So consider these three sides. I've color-coded them just so you can see them in the next one as well. If I take the same 3 side lengths and attach them to actually form a triangle, those triangles have to be the same. Maybe flipped, maybe rotated, but they have to be congruent. So all three sides the same means that they're congruent. Next, two sides and the angle between them. So this side, and this angle between them. If I've set that angle and I have the two side lengths, it doesn't matter how I draw them out. If I connect the third line connecting them, it has to be the same as each other. Those two triangles have to be congruent. And finally, if I know two angles and the side between them is the same, So this angle here that I've set and this angle here, if from this angle I just draw out a line and from this one I draw out a line, they have to meet somewhere. Those are like the lengths. If I just sort of draw out the shorter versions of them, that's what the triangle does. And if I take that same green length and these same two angles on either end, it doesn't matter which is which, and I drew out lines from the end at that angle and the end at that angle, those would have to be the same lengths as well. So two angles and the side between those two angles, that's a sufficient condition to prove that two things are congruent. I'll save this for the next one. So next video lesson, what kinds of questions can you expect to see? That's the intro to congruence.